We've all been told the universe is constantly expanding. It's almost become background noise to us, something we've known since our school days. But have you ever wondered why that's important? What would happen if all that cosmic motion came to a sudden halt? Think of the universe as a giant balloon inflating continuously. This expansion is driven by an invisible and puzzling force known as dark energy. But if the universe were to stop expanding, it would be as if the air filling our metaphorical balloon suddenly ceased, a halt that would imply a significant shift in the cosmic forces at play. Dark energy and gravity are locked in an eternal tug-of-war. While gravity tries to pull everything closer, dark energy is pushing everything apart at an accelerated pace. This balance of forces shapes the universe's structure, with galaxies and vast voids forming a cosmic web. If the expansion were to stop, the delicate balance would be disrupted. The effect on the cosmic web could be catastrophic, leading to a complete breakdown of the structures we observe today. This breakdown would also impact the mystifying substance known as dark matter. Dark matter, although invisible and detectable only through its gravitational effects, plays a crucial role in holding galaxies together and in the large-scale structure of the universe. It's the glue that holds the cosmic web together. But what happens to this glue when the universe ceases to expand? Current theories suggest that dark matter would become increasingly erratic. Its gravity could become more influential, leading to a greater clumping of dark matter. This would result in increased gravitational anomalies, and potentially even cause a restructuring of the universe on an unprecedented scale. It's also possible that the relationship between dark matter and ordinary matter would change fundamentally. Dark matter might start to interact differently with regular matter, leading to new, currently unknown physical phenomena. Our understanding of the cosmos could be turned upside down. This collapse wouldn't just affect galaxies and stars. It would extend to the tiniest particles that make up matter. Now, let's consider light, our primary tool for observing the universe. The light from distant galaxies experiences a phenomenon called redshift due to the universe's expansion. As the light travels towards us through expanding space, it shifts towards the red end of the spectrum. This change in wavelength is one of our key tools for measuring the universe's expansion rate and its distance scales. But if expansion ceased, so would redshift. The light reaching us from distant galaxies would no longer stretch as it travels through space, altering its perceived color. This would profoundly impact our ability to study the universe, and could render the most distant galaxies invisible to our observations, wrapping the universe in an enigmatic cloak once again. Remember, we're barely scratching the surface here, and these initial thoughts are based on our current understanding of physics. The reality could be different. The laws of physics might alter in a universe that has stopped expanding. If the universe's expansion were to halt, the gravitational pull would become the dominant force. Imagine an ocean, where gravity is like the water current pulling everything towards the seafloor. In an expanding universe, we've been comfortably floating around, defying this current thanks to dark energy. But once the expansion stops, everything would start sinking towards gravity's pull. The galaxies that we see scattered across the universe, from the Milky Way to Andromeda and beyond, would gradually start coming together. Eventually, they could merge, leading to a colossal pileup of cosmic proportions. This Big Crunch scenario, as it's known in cosmology, would result in a singularity, a point of infinite density. Everything that we know, galaxies, stars, planets, life, the fabric of space-time itself, would be compressed into this singularity, just as it was in the moments before the Big Bang. However, there's another aspect we need to consider: the fate of stars. Stars, including our Sun, rely on a delicate balance between gravity pulling inwards and the outward pressure produced by nuclear fusion in their cores. If the universe stops expanding, could this balance be affected? It's unclear. But if gravity were to become stronger, it might hasten the life cycle of stars, leading to premature supernovae. These consequences might sound terrifying, but remember, this is all speculative. We don't know for certain if the universe's expansion could stop. Current evidence suggests that not only is the universe expanding, but this expansion is also accelerating due to dark energy. If anything, in the distant future, we might be faced with a different scenario: the Big Rip, where dark energy becomes so dominant that it tears apart galaxies, stars, planets, and even atoms. As it turns out, time and space are intimately linked in what we call space-time, the fundamental canvas of our universe. The expansion of the universe isn't just the stretching of space, but also the forward march of time. So, if the universe were to stop expanding, would time stop too? Here's where things become a bit dicey. Our understanding of physics as we know it is not quite equipped to tackle this question head-on. However, some theorists suggest that if space were to stop expanding, time could indeed come to a standstill. In this timeless universe, nothing would happen, nothing would change, it would be a frozen snapshot for all eternity. Yet, some others argue that even if the universe stopped expanding, time would continue forward. After all, even without cosmic expansion, we still have local motions. Planets orbit around stars, stars orbit within galaxies, and all of these are processes that occur over time. Perhaps time, in this context, would become more localized, tied closer to gravity and mass than the fabric of the universe itself. What about life? The cessation of the universe's expansion and the resulting gravitational dominance would likely wreak havoc on the cosmic structures that support life. However, this wouldn't happen instantly. There might be a gradual shift, during which life forms could possibly adapt or evolve to the new cosmic order. Or there might be a sudden cataclysmic shift, in which case adaptation would be less feasible. So far, we've discussed the physical aspects of a halted universe, but this scenario also has deep philosophical implications. A universe without expansion would be fundamentally different from the one we know and understand. This change would undoubtedly force us to reconsider our place in the cosmos. Imagine existing in a timeless universe. How would our perception of life change? Without the forward march of time, the concepts of past, present, and future become irrelevant. Life as we know it is structured around time. Our daily routines, aging, even our thought processes are all time-dependent. If time were to freeze, life would become a series of static, unchanging moments, a hard concept to grasp for beings so bound by the flow of time. However, some philosophers argue that even in a timeless universe, consciousness could still exist. After all, our awareness doesn't necessarily rely on the progression of events, but rather on the immediate experience of a moment. Consciousness, then, might exist as an eternal, unchanging now. So, the next time you look up at the night sky, don't just see a beautiful spectacle. Instead, recognize the incredible drama unfolding above, a story of expansion and evolution. If you found this video interesting, don't forget to give it a thumbs up and subscribe for more content. And as always, stay curious, keep exploring, and let's dive into the mysteries of our universe together.